Now we are going to discuss Newton's second law of motion. The definition of Newton's second law of motion as given in the Principia is not taught in the textbooks. Newton did not give the equation F equal to ma for the second law of motion. Swiss Leonhard Euler had given F equal to ma in 1776. Scientists arbitrarily interpreted the original definition of Newton's second law of motion so that it appears to give F equal to ma. Further, the textbook definition of Newton's second law of motion is based on F equal to ma, which was never written by Newton but by Euler. Basis of the discussion is paper presented at the Euler Society Conference 2014 in Texas, USA, other conferences and published in journals. The papers are also in press in Scopus Indexed Journal. This discussion will also appear on www.newton99.com and YouTube channel. So part 1, general discussion about Newton's second law. What is Newton's second law of motion? In which book and when did Newton give the second law?
Newton wrote an epoch-making masterpiece, Mathematical Principles of Natural Philosophy, in 1686, while he was a professor at University of Cambridge, England. The book is popularly known as the Principia, contains 8 definitions, 3 laws of motion, and law of gravitation, etc. The law was given in the Principia at page 19 as, I quote, "The alternation of motion is ever proportional to the motive force impressed and is made in direction of the right line in which the force is impressed." It is an original or bona fide definition of the law. The Principia was initially written in Latin, then it was translated into English by Andrew Motti in 1729, that is 2 years after death of Newton. Here we are considering the linear motion, that is movement of body in straight line.
However, this definition of Newton's second law as given in the Principia is not taught in standard textbooks. In the textbooks of National Council of Educational Research and Training, New Delhi, a different definition is mentioned. The rate of change of momentum of body is directly proportional to the applied force and takes place in the direction in which force acts.
It is true, we have 2 second laws of motion, that is Principia's second law of motion and other law in the prevalent textbooks. The definition of Newton's second law of motion is different in the textbooks than given by Newton in the Principia. However, the definitions of the first and third laws of motion are the same in Newton's Principia and existing textbooks. Scientists have only changed the definition of second law of motion purposely. No reason has been given why Newton's second law has been changed in the textbooks from original definition. It is simple question of why only definition of the second law of motion has been changed arbitrarily. When it was changed, who changed it? No reason has been cited for the same in the textbooks or other monographs.
What is the equation for the second law of motion?
Newton did not give any equation for the second law of motion. Before Newton, natural philosophy was a prevalent stream of knowledge. Natural philosophy means combined study of mathematics, medicine, astronomy, philosophy, physics, chemistry, etc. Newton separated physics from natural philosophy and developed physics as a subject. Further, Newton explained phenomena geometrically with help of theorems, propositions, figures, lines, not with mathematical equations. The study of phenomena with mathematics started predominantly by Euler after death of Newton in late 1720s and 1730s. So mathematically, Newton's second law of motion is expressed as force is proportional to change in motion. Now motion is understood or described in terms of velocity. Hence force is equal to constant change in motion, or F is equal to dV. Incidentally, now computer programming and artificial intelligence are used to study the phenomena.
Part 2. Scientists agree that F equal to ma was not given by Newton, also changed definition of the second law of motion without giving any reason. But in the standard textbooks, F equal to ma, or force equal to mass multiplied by acceleration, is taught as the equation for the second law of motion. However, you say that Newton did not give any equation for the second law. Then why is F equal to ma taught in textbook as the equation for Newton's second law?
Equation F is equal to ma was given by Swiss Leonhard Euler in 1776 in paper code number E489 on pages 222 to 223. For ready reference, these equations can be seen at the website www.eulerarchive.ma.org. Euler has also given equations of force F is equal to ma/n in 1736, F is equal to 2ma in 1749 and 1752, and third equation F is equal to ma over 2g in 1765. These equations may be found in Euler archives at paper codes E15, E112, E117, E289 and E479, etc.
However, scientists agree that F equal to ma was not given by Newton.
Yes, Newton did not give F is equal to ma, which is regarded as equation for second law of motion. It is accepted and quoted by Institute of Physics, England, IOP England, states that Newton did not include an explicit numerical measure or symbol for acceleration in his work. The expression of his second law as F is equal to ma first emerged more than half a century after the Principia was published in a paper by Euler. It can be seen on the website www.spark.iop.org/development Newton's first law. Also, Newton did not define acceleration. These facts are supported by various scientists and scientific organizations dealing with history of physics. F is equal to ma does not follow Newton's second law of motion. However, it is arbitrarily derivable from Newton's second law of motion by scientists to try to derive F is equal to ma from the law.
There would have been some reasons or resemblances that scientists associated F equal to ma with Newton's second law of motion.
The definition of Newton's second law of motion involves force and motion. Newton did not define motion. He gave reason for this in the Principia on page 9 that like space and time, motion was already well-known term. Here Newton even did not mention how motion was defined by the previous scientists and what Newton himself meant by motion. So the following scientists used motion in the most vulnerable term and interpreted the same as it suits the Principia form of second law of motion, so that F is equal to ma may be obtained from it. Secondly, Euler's equation F is equal to ma also involves force and acceleration. The scientists arbitrarily interpreted change in motion as rate of change of momentum, or ma, So that equation for Newton's second law of motion becomes F is equal to ma. Thus acceleration also comes in picture of the second law of motion. Thirdly, the force is found in both Newton's second law of motion and Euler's equation F is equal to ma. Further, in Newton's definition, term change in motion occurs and acceleration in F is equal to ma. So scientists try to connect change in motion with acceleration, assuming that change in motion is equal to rate of change of momentum. They regarded change in motion is equal to rate of change of momentum equal to m dv over dt equal to mass into acceleration. Point number 3. Also in the 17th to 19th century, Newton was synonymous with knowledge and F is equal to ma was the most significant equation. So the most significant equation was associated with the greatest scientists. Afterwards, in the standard textbooks, Euler's name was not mentioned with F is equal to ma by the scientists. So possibility of any doubt of attribution of F is equal to ma to Newton's second law of motion was eliminated. Otherwise, students would have asked why Euler's name is not associated with F is equal to ma.
You have pointed out that scientists have arbitrarily interpreted the change in motion as rate of change of momentum or ma. How you can justify it?
F is equal to ma is associated with Newton's second law of motions arbitrarily and unscientifically. For example, Raman quoted the theme of existing literature in the journal The Physics Teachers published by the American Institute of Physics in March 1972. Raman equated change in motion with different quantities, change in momentum, rate of change of momentum, depending upon his own convenience to obtain F is equal to ma from Newton's second law of motion. Initially, scientists assumed that change in motion is equal to change in quantity of motion mdv, and they get equation F is equal to k mdv, which is not equal to F is equal to ma. Then scientists made more arbitrary assumptions that change in motion is equal to rate of change of momentum, and thus they get the equation F is equal to ma if k is unity. Thus existing derivation is based on arbitrary assumptions and not justified.
Has the International Union of Pure and Applied Physics, that is IUPAP, recognized motion as a physical quantity?
Motion is an effect that describes the state of movement of a physical body. International Union of Pure and Applied Physics IUPAP has not put motion in the list of physical quantities. The motion does not have any symbol, unit or dimensional formula. Motion is a scalar and it is not associated with any mathematical equation. Whereas velocity is a physical quantity, the symbol for velocity is generally regarded as u or b. The units of velocity are meter per second, 10 meter per second, say, and dimensional formula m0L(t)-1. The simple equations related with velocity are v is equal to u plus at v square minus u square is equal to 2as, etc. J. Jennings in 1721 defined velocity in the book Miscellanea as velocity is equal to distance travelled by time taken. There is no such equation related to motion in physics or science. Motion cannot be equated with velocity, momentum, acceleration. In physics, only those quantities can be equated which have same units and dimensions in left hand side and right hand sides. In basic physics, the terms are equated if they have the same units and dimensions. As motion has no units, velocity has units. Both cannot be equated. And here motion is a scalar, velocity is a vector, thus equating change in motion with change in momentum and rate of change of momentum is completely unscientific.
Third part of the discussion, to establish the truth about the second law of motion. Also, at some stage, some scientists might have realized the truth that neither acceleration nor F equal to ma was given by Newton. Who was that scientist?
First of all, American historians of science C. Truesdell published a detailed paper in the journal Archive for History of Exact Sciences in 1960 that F is equal to ma was given by Euler in 1752 and never by Newton. However, F is equal to 2 ma was given in the said paper. Euler precisely gave F is equal to ma in 1776 when he was a professor at St. Petersburg Academy of Sciences. It is pertinent to mention here that Euler has given the equations F is equal to ma over n in 1736, F is equal to 2 ma in 1749 and 1752. F is equal to ma over 2g in 1765 and finally F is equal to ma in 1776. Truesdell did not mention all these equations. Further, he added that F is equal to ma is easily derivable from Principia's definition of Newton's second law of motion, hence not raising the issue of the inconsistent derivation of F is equal to ma in the literature.
Truesdell pointed out the truth that F equal to ma was given by Euler in 1752 and not by Newton. What was the effect of this revelation on the scientific community?
In 1972, in the journal Physics Teachers published by the American Institute of Physics, Raman inquired why Euler's name is not associated with F is equal to ma in textbooks. Raman specifically quoted that Truesdell has pointed out more than a decade ago. The Euler gave F is equal to ma. Raman also tried to obtain F is equal to ma from the Principia's form of Newton's second law of motion by inconsistent method as explained in question 7.
American historian of physics Bernard Cohen is the greatest scholar of Newton's work. Bernard Cohen is also the author of the famous translation and explanation of the book Principia, published in 1999. This book contains about 1000 pages and explains the Principia decently.
Yes, you are right. What Cohen's work needs to be carefully interpreted on the topic, that is regarding interpretation and quotations of Newton's second law of motion. Cohen did not critically analyze the history of F is equal to ma and Newton's second law. Firstly, in the illustrated version of the Principia, Cohen did not write that F is equal to ma was given by Euler, not to speak of Euler's other equations F is equal to ma over n, F is equal to 2 ma and F is equal to ma over 2g, etc. Why? Secondly, Cohen gave various references to Newton's work in the book. What he did not mention, Truesdell's comments that F is equal to ma was given by Euler in 1752. Cohen did not write a word about Raman's remarks in the journal The Physics Teachers, published by American Institute of Physics. Why? Thirdly, further Cohen in the book on the pages 112, 113 quotes proposition 24 of book 2 of the Principia but partially. The complete translation is given by Andrew Mott. It can never be regarded as F is equal to ma, as Newton did not mention velocity increment and time increment. However, Euler specifically mentioned velocity increment in the corresponding increase in time in the book Mechanica in 1736, and also their ratio mathematically, which is acceleration. Thus, Cohen's interpretation is incomplete in this regard. Original equation based on the definition of Principia is F is equal to K dV. What Cohen did not write this equation in the detailed book. This book has two parts. First part is a guide to Newton's Principia, pages 3 to 400, and second part illustrates translation of the Principia from various existing translations, pages 401 to 966.
What are your main contributions regarding this topic?
Firstly, it is pointed out why scientists neglect the original Principia's definition of the second law of motion. Secondly, why scientists do not mention F is equal to ma as given by Euler. Thirdly, why do scientists arbitrarily derive F is equal to ma from Principia's form of second law of motion? However, they do not mention Principia's form of the second law in the textbooks. The scientists quote the definition of Newton's second law of motion in textbooks as based on equation F is equal to ma. These points are specifically pointed out in the discussion. The author discussed these issues specifically in an unbiased way in detailed papers posted on website www.newton99.com along with discussion. A detailed discussion is also published on YouTube. The book Newton's Laws of Motion in 21st Century is in progress.
If scientists agree that F equal to ma was not given by Newton, why do scientists not state the same in standard books?
F is equal to ma is equation for Newton's second law as established over 200 to 300 years ago in textbooks, research notes, other documents, etc. Scientists argue that scientific and industrial developments are based on Newton's laws of motion. Euler name is not mentioned in the textbooks. That he has given F is equal to ma. It is the main issue. It is correct that Truesdell and Raman have raised the point. What in a single sentence is not sufficient. This issue requires global interactions at various scientific institutions. We should remember that for about 2000 years, the sun revolves around the earth. However, the mode of communications are faster nowadays, so people can understand even the different scientific opinions quickly.
Thank you.
Thank you.